Hi there, this is Jacob Nash, Algebra Lessons. Precalculus Lessons. Got mixed up, said the other thing 200 times. Okay. Just so you know, in case you didn't know, there's also Jacob Nash Algebra Lessons, and Engineering Lessons, and Geometry Lessons. In total, I've probably made over like 600 videos. Actually, probably not that much, but seems like at least. So, sorry about that. Pre-calculus lessons, not algebra lessons. And I have a headache, so yeah. So, this is a video, lesson 4 for Unit 1, on end behavior and horizontal asymptotes. And you might say, great, not another one of those dumb asymptotes. You might say that, if you get what I mean. But, you know, it's what you have to know. So, end behavior in Algebra 2, you might have learned as that end behavior is to as x goes to y goes to whatever. Not equals, that's not what it's supposed to be. It would just have another arrow. But that's not what you do for this. So you instead state it like you did for limits, which was the last lesson, when you have those lim, fx, things like that, which you might think is more dumb, but that's just how it is. So, a horizontal asymptote, it's not a discontinuity, because we're talking about discontinuities as far as for the x. It does, a horizontal asymptote would break up the values for the y, but not for the x necessarily. So, don't get mixed up. Horizontal asymptote, that would mean an equation that says y equals something, because that's what it's like if something's horizontal. Okay. These are the rules of horizontal asymptotes, and you learn this in Algebra 2, but here's what it is again. So, there's 3 different things, and so let's pretend that p is an exponent, well, not just any exponent, the degree, and remember, the degree is the highest exponent that there is. And it's supposed to be first if it's in standard form, but sometimes they'll make a problem dumb and it will just not be first. So make sure that you look at all of the exponents that there are and see which one's the highest. That gives you the degree, which in this case we're calling p. Now the degree of the denominator, let's call that q. If p is greater than q, so if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. That makes sense, because then it would simplify to just a line in some cases, or which doesn't have a horizontal asymptote in many cases. If p is less than q, so if the degree of the numerator is less than the degree of the denominator, then we have a horizontal asymptote at y equals 0, which means the y equals 0 line is basically just the x-axis. So that means no points can go through there. Remember, that's what an asymptote is. It's like, sorry, no, can't, the line can't go through that place, or that doesn't work. So if p equals q, so if the degrees on both are the same, then how you find the horizontal asymptote is you look at the numerator's coefficient, which is the leading coefficient, and the leading coefficient is on the term that has the degree that you looked at to determine that you would need to do this in the first place. So that coefficient divided by the denominator leading coefficient is how you find the line for that. And if that doesn't make sense, maybe it will when you see these practice problems 3. For these problems, we're supposed to find the horizontal asymptote and end behavior. What we can do to do this is first find the horizontal asymptote by using this table right here. Then make a rough graph of the function. By rough, I mean that you're not even going to actually put numbers on there. You're just going to draw what it would roughly look like. And you can figure this out by looking at the leading numerator and denominator terms. Then state the end behavior in limit form. All right, number 1. Let's find out if there's a horizontal asymptote first. How do I get rid? Okay, there we go. So, you have to look at the degrees of the numerator and denominator. Well, the denominator is pretty much 1 since there's nothing there. Let me, if you've watched many of these videos, you might think, by now, wouldn't he know that's always what it does? I always forget that this dumb thing does that if I click undo. So really it's over 1 because there's nothing there. So what is P? You don't necessarily have to do this if you understand already, but I'm just going to tell you this. So P we call the leading, the degree of the numerator. So what's the highest exponent we see there? 2. That means that the the degree of the numerator is 2. What about the denominator? There's no x there, and that really means the degree is 0, because if there was an x to the 0, that would mean 1, so no x at all. So, but regardless, P is greater than Q, and we said if that's the case, then there is no horizontal asymptote. So, horizontal asymptote is, well, we could do that, but really the proper thing to do is does not exist. Okay, now we need to find out, make a graph, rough graph of it. So this is going to be a quadratic since it has the highest exponent is a square, and since the leading term has a negative on it, that means it'll point down. And we know that quadratics are a parabola, or they look like a U. So that's kind of what it would look like, but it would have transformations. So now what we do is we figure out the end behavior. So we say the limit of f of x, that's what it is. So what is that? As x goes to negative infinity. So as the x values go to the left, what do the y values do? They go to negative infinity. Then what about as x goes to infinity? So to the right, still negative infinity. And that would be our end behavior for that one, because that's what it's like. Now, we can look at the next 2 problems here. So, that was that one. Well, actually, one thing that you can do is you can say that it does not exist also, because in some terms you couldn't have an answer that is negative infinity or positive infinity, but we can just leave it as that, but keep in mind that you can see it as do not exist sometimes, or does not exist. Alright, number 2, horizontal asymptote. Leading degree, or the degree of the numerator to degree of the denominator is also 2, because that's the highest one there. Since they equal each other, that means you have to figure out the coefficients, like the leading coefficients, and that's what it is. So y equals leading coefficient 3. Don't say 6 just because it's first. It has to be the one with the highest exponent. So negative 4. So negative 3/4 is y equals negative 3/4 is the horizontal asymptote. Alright, now draw a rough graph. This time on the graph, we're going to put a horizontal asymptote here. That didn't really turn out to be dotted, but now we got to figure out what kind of graph it would be, and we can just look at the terms, the leading terms, so on the numerator denominator, which is 3x squared and negative 4x squared. The x squareds would cancel out, and we would just get a negative 3/4. But if we were to graph this, I'll put this into the graphing calculator real quick. 6x. Alright, I'm clicking graph. And because that cancels out, that would mean that we have a rational function. So, the rational functions always look like this, but they would just stop at that asymptote. So that's what it would look like. Now, state the end behavior. So, as the x values go to negative infinity or to the left, the y values, well, in this case, it would actually, we would look, the y values would go to negative infinity. But we could say it does not exist also. But, okay, now as x values go to positive infinity, or to the right, the y values go to negative 3/4, because that's what our asymptote is. So that's the answer for number 2. Number 3, last one. So on here, let's look for the horizontal asymptote. And remember that you always have to have y equals something for the horizontal asymptote. Alright, degree of the numerator, 1. Degree of the denominator, 2. Since it's greater on the denominator, it's always y equals 0. Okay, so rough graph now. So right here at the x-axis, let me just do that in different colors so you can see. The y values cannot go to right there. Now, a rough graph, we do the leading terms. 4x squared. 4's would cancel out, and there would be an x on the bottom. 1 over x. Okay. Also rational. So it would look like this. Now, last thing in behavior. As the x values go to negative infinity, the y values also do that. As the x values go to positive infinity, the y values go to 0. And there you go. That would be the end behavior for that one. So, that's it for this video on end behavior and horizontal asymptotes. And hope this made sense. And that'll be it for this video. I'll see you on the next one.